Welcome, everyone, to this explainer. I am absolutely thrilled you're here today because we are going to look at something truly mind-expanding. We're diving into a visionary initiative from a company called LINKSPREED LLC. Their project, WorldID, is proposing a total revolution in how we index, track, and understand physical space itself. We are talking about fundamentally rewiring the foundational layer of how our physical geography couples with our digital identity.
Okay, let's dive into this. Imagine, just for a moment, a world where every single square meter of the Earth's surface possesses its very own, absolutely unbreakable digital fingerprint. It sounds like massive, sci-fi-esque ambition, right? A perfectly mapped planet where the exact patch of dirt you are standing on right now has a unique mathematical identity that is universally recognized. Well, that is exactly the core premise of the WorldID initiative. To get why this is so revolutionary, we really have to talk about the invisible flaw in how we do things right now. You use standard GPS coordinates. Actually, the technical term is WGS84 every single day. But here's the glaring problem. Those coordinates are variable. They literally drift around. And worse, they rely almost entirely on centralized databases to tell us where things are. If you want to index the entire world, centralized storage creates massive single points of failure. If a server goes down or gets hacked, the map of our reality effectively just breaks.
Section 1. The problem with GPS and fixing our drifting reality. So on one side, we have our old way, variable GPS coordinates. They're shaky, they're drifting, they're highly vulnerable, and they require these massive, expensive, centralized server farms just to be stored and recalled. On the flip side, we have the new way proposed by LINKSPREED, static UID fingerprints. These are immutable, meaning they are locked in and cannot be changed. They're decentralized, and most importantly, they are calculated on the fly rather than stored. We are basically moving from a shaky, drifting foundation to an ironclad, deterministic grid. Section 2, meet the UID, the micro-level blueprint. Let's zoom way, way down to a single square meter of land to see how this actually works. The core of this entire ecosystem is the UIID, which stands for Universal Immutable Identifier. Simply put, it's a unique 256-bit cryptographic fingerprint that permanently anchors data to one specific square meter of geographic space. It's universal, so it applies globally without exception. But the absolute genius here is that it's derived directly from the physical coordinates of the Earth by sheer mathematical necessity. It is not some random number assigned to that patch of dirt by a vulnerable server somewhere. The math itself dictates the ID. And this brilliantly illustrates how the normalization process happens in 3 really distinct steps. First, you segment the entire surface of the Earth into a precise 1 square meter grid. Second, a device calculates its coordinates totally locally. And third, it outputs the exact same UID fingerprint. Because it's mathematically derived, any device, literally anywhere, will calculate the exact same UID for that exact same square meter. Suddenly, shifting, drifting points are transformed into a permanent, static grid. Section 3. The math of certainty, scaling up to global security. Now that we've looked at 1 square meter, we need to zoom out. If we are assigning a unique cryptographic fingerprint to every single square meter on Earth, we absolutely have to talk about mathematical safety. We have to ask the big question: how safe is a 256-bit fingerprint? If the entire global economy is relying on this, is there any chance we run out of identifiers, or that 2 places accidentally get the exact same fingerprint? To answer that, 0.62 zeros followed by 4%. Just let that sink in for a second. The Earth has approximately 510 trillion square meters of surface area. If we map every single one of those 510 trillion square meters using this 256-bit address space, this astronomically tiny fraction is the percentage of the address space we would actually use. To put it another way, the scale of a 256-bit address space is just beyond human comprehension. If you assigned a unique UID to every single atom on the surface of the Earth, and I mean every atom, not every square meter, you would still have used less than 1/billionth of 1% of the available addresses. The density and capacity of this ecosystem are, for all practical human purposes, infinite. It's completely staggering. So, the crucial point is collision resistance. Because LINKSPREED uses SHA-256 encryption, a hash collision, which is where 2 different physical places accidentally calculate the exact same ID, is statistically impossible.
As the source material wonderfully puts it, you are 10 to the 45th power times more likely to be hit by a mass extinction level asteroid in the next second than to witness a UIID collision. Your 1 square meter of Earth is mathematically sovereign and completely uniquely yours. Section 4, the WorldID workspace, bringing it back down to Earth. Let's pull this abstract math back down to reality. How will companies, governments, and everyday folks actually use this global decentralized framework? Well, LINKSPREED envisions what they call the WorldID workspace. Think of it like this. The UID provides a totally rigid, unmoving physical grid. On top of that grid, you can overlay data layers like transparent sheets, environmental metrics, land titles, logistics routes, giving everything absolute global context. And because of zero storage truth, massive server storage costs are eliminated entirely. Why? Because the grid is calculated on the fly, not stored in some expensive database. Finally, it creates incredible interoperability. Every organization, no matter what software they use, can interact seamlessly because they are all speaking the exact same mathematical language. Having this ultra-reliable Internet of Places basically unlocks incredible futuristic technologies right now. Autonomous drones can navigate and verify precise landing zones completely locally, without ever needing to check in with a cloud database. We can finally build true smart cities, where every digital twin has a precise UUE, acting as an ultra-secure data container. And in Web3 and real-world assets, we finally have a flawless, cryptographically secure bridge connecting physical land directly to smart contracts. It's a total game-changer. Let's move to and see how this builds into Section 5, to the stars, the cosmic scale. Now, what's really interesting about this slide is it proves that if this framework is mathematically universal, why stop at Earth's atmosphere? This system scales perfectly to absolutely any celestial body that has a defined coordinate system. Just look at these numbers. Earth has 510 trillion 1 square meter UID slots, but Mars has 144.3 trillion. The Moon has 37.9 trillion. The roadmap for LINKSPREED literally extends far beyond terrestrial boundaries. This creates an unprecedented interplanetary workspace. Think about the Artemis missions, increasing human presence on the Moon. They're already looking at adapting a Moon ID to support autonomous lunar mining and habitat management. Or consider Mars. The communication latency between Earth and Mars is a massive, massive hurdle for space exploration. But with a deterministic UID system, a Martian rover can identify its precise location locally, in an instant, without waiting for a signal to bounce all the way to a terrestrial server and back. Ultimately, what the WorldID initiative represents is a profound, historic shift. We are moving away from an era of fragile, stored truths, where our reality is constantly dictated by vulnerable, centralized databases, and moving toward a mathematically flawless, calculated reality. The WorldID workspace is essentially an open invitation to securely organize our planet, and eventually the stars, 1 square meter at a time. It really leaves us with a fascinating question to ponder. When the very reality we walk upon is mathematically calculated, what boundaries are left that we cannot cross? Thank you so much for joining me for this explainer, and definitely keep your curiosity alive.